I'm Caitlin. I am the soil specialist. I love to talk about soil, so if you really want to ever just have a chat, we can do that. Does everybody soil sample or have taken soil samples within the last 3 years? Good, love that. And so we have a new resource that's just a very brief overview of how to read a soil sample. I think it's in your packages and stuff, but we can get into a little bit more in depth later too. So today I'm going to talk about some of the things that are on that soil test report, particularly, as Rosie had mentioned, pH, organic matter, and cation exchange capacity, as they're going to talk about the nutrients more specifically. So what I really want to do is make sure that we're putting this in context of your nutrient management plan. Because I can talk to you guys about what pH is for hours, but if you don't know how to understand why that pH is important, that's what we really want to target today, and how you can manage that pH to make the best use of your nutrients on farm. So just in terms of nutrient management planning, just some very quick things I always think about when I'm thinking about nutrient management planning is making sure there's an appropriate amount of nutrients on your farm, making sure they are available when you need them, so we'll talk about that a lot, and then also keeping your nutrients on farm. So an important thing to remember is that when a lot of nutrients are on farm, they're nutrients, but when they're off farm, they're pollutants. So like nitrate can be pollutants to the environment. So we really want to keep those on farm and available. So I've said available a few times, so when you think about your nutrients, you want to think about their availability. So when are your plant nutrients available? And when I say available, that means that the plant can take them up. So there are many factors that affect when nutrients are available, such as pH, organic matter, your soil physical properties. But your nutrients are available when they are in the plant available form, when they're in soil solution, and usually when they're in close proximity to the root. So I'm going to talk about those things, and as we go through, I'll come back to those three topics a lot. So first one, we're going to talk about pH. So if you're unsure where your pH is on your soil test report, it's number 1. So you have your pH, buffer pH, and your lime recommendations, which all have to do with your pH. So what is pH? It's your measure of soil acidity. So it measures the active hydrogen ions, so your positively charged hydrogen ions in the soil solution. It's on a scale of 1 to 14, where anything below 7 is considered acidic, anything above 7 is considered alkaline. And the other thing is that pH is on an inverse logarithmic scale. And so for what that means is for every unit increase in pH, there is a 10-fold decrease in those hydrogen ions in your soil solution. So this is just kind of a scale here. Typically, you would want, but for most crops, you kind of want that 6 to 6.8 pH range, but that can change per crop. Particularly for blueberries, they prefer more acidic soil. So that's an important thing to make sure you know your pH on your soil test report, and you also know what type of pH, what pH range your crop likes. And if you're outside of that pH range, it doesn't necessarily mean that your crop's not going to grow. It just there's an ideal pH range for your crops. So I said, why are Nova Scotia soils acidic? So overall, in Nova Scotia, our soils are typically acidic naturally. So oftentimes we have to apply lime because we want that pH to be brought up to usually within that 6 to 6.8 range. So there are natural reasons why our soils are acidic. One, we have naturally acidic bedrock material in a lot of the province, not all of the province. 2, when organic matter decomposes, which is a natural process, they do release some weak acids, which can increase the acidity. Podsilization, that's a natural soil forming process in which nutrients are leached downward through soil, which happens in Nova Scotia quite a bit. And then plant uptakes, and we'll talk about that a little bit more. But there also are some anthropogenic, so human reasons why our soils are so acidic. 1, lingering impacts from acid rain in certain cases, but mainly for farming, adding nitrogen fertilizer and harvest can decrease your pH. So for those of you who have your soil test reports, are your soils typically acidic? Or were they acidic before you added any amendments? Yeah, that's typically the case. So what happens when your soils are acidic is that you can have leaching of cations. So I said we were going to talk about cations. So these are your positively charged ions in soil. So you have basic cations and you have acidic cations. So your acidic is your hydrogen, which is your measure of which measures your pH. And then aluminum is also acidic, and then your basic ions are calcium, magnesium, sodium, and potassium. So when your soils are acidic, these can be leached, and it can lead to deficiencies of these nutrients. And then aluminum and manganese toxicity often happens. And there can be a decrease in organic matter decomposition because there are also certain ranges in which microbes prefer their pH, and therefore a decrease in mineralization where those nutrients are becoming available. So the reason for that, and I'm not sure if some of you have seen this one or this figure here or something similar. So this is different pH ranges and where your nutrients are of plant available. So when you have your low pHs, you can see that aluminum and manganese, there's more abundant, and in high amounts in soil they can often be toxic. So that's an issue. And then in higher pHs, that's where your calcium becomes more available. And phosphate is very pH dependent for its availability as well. An important thing to remember is that these nutrients are not solely based on pH, whether they're available. There are other factors that contribute to it. So when we think about a value of a good pH, so there's a few other things that, that you want to consider. So your nutrient use efficiency decreases a lot with a lower pH. So if you have a pH of 6.5, your overall fertilizer efficiency is approximately 86%. And this will change slightly based on soil conditions. And then if you have a pH of 5, you see that overall fertilizer efficiency is only at about 46%. In addition, you can look at it in terms of yield. So this fact is just from a meta-analysis study, a global one. So it may not be specific to this one, but they've seen on applying lime, so increasing your soil pH on acidic soils, you can see yield increases of upwards of 40%.
I can't see those numbers on the chart. Can you make it a little bigger? It's actually in your handout. Oh, thank you.
Yeah.
So there's a soil, Nova Scotia Soil Need Lime. It's one of the ones that was on the table.
So Nova Scotia Soil Need Lime, and it's also in the value of maintaining a good pH fact sheet. Yeah. Yeah, so if you don't have that fact sheet, it's over there, and it explains where those numbers came from a little bit more. Yeah, so I've talked about it a few times, but in order to amend your pH, liming is often used. So there are lots of different liming materials. These are actually pictures from my master's project, so that's why I like to show them up here. So there's different types of amendments. So we have calcitic lime, which is calcium carbonate, dolomitic lime, which also contains magnesium. So when you're considering what type of liming amendments you want to use, these are things that you can look at. So if your soil test report for some reason has a higher amount of low calcium, but you have an abundant amount of magnesium, you may want to consider calcite over dolomite. There are other liming agents, such as wood ash and others, and a lot of times the liming amendment that you choose is largely based on transportation costs, so that's something you have to look at too. Because there's only two places in Nova Scotia that you can get lime from. One's Mosier Limestone in Upper Musquodoboit, and then Antigonish lime in Antigonish. So when you are looking at your liming material, so on your soil test report, they typically will have a lime recommendation at the bottom there, the LR, and that's telling you the amount of calcium carbonate needed to adjust your soil pH to 6.5. So what's important to remember there when you're considering your liming recommendations is if you are using something other than calcium carbonate, you may have to adjust those values. So you can adjust them based on what's called the calcium carbonate equivalency. And what's important to look at here is, so calcium carbonate should have a calcium carbonate equivalency of 100%. And that's what the other liming amendments are based off of. So this can change based on what's called the fineness factor. You can get that value from the liming, like where you buy lime, you can ask them for that. So that may alter it a little bit, but typically we say 100%. So for different, if you're getting like wood ash, typically their calcium carbonate equivalency can range anywhere from 20 to 40%. So if you are looking solely for a neutralizing agent to bring up your soil pH, you would likely have to apply more. But you also have to consider that there's other things in wood ash or other amendments. So other considerations when you're looking at liming and nutrient management planning is if you incorporate lime, it's faster acting because it interacts with the soil particles. The more surface area it can hit, the faster acting it will be. If you're not incorporating lime, it can take up to 2 to 3 years for it to be fully effective, and this is often based on your soil properties and the where your pH started at. So if you have a lower pH, typically you'll see a spike in increase, but again, that depends on your physical soil properties like texture. If you are able to apply lime in the fall, especially if you're not incorporating, that's great because that gives you time over the winter for it to act. So I just want to recap quickly nutrient management planning and pH. So it's the main points that you need to know when you're thinking about nutrient management planning. One is what pH range your crop desires, what your current pH is, and what the lime recommendation is. So that tells you, do you need a liming agent? What liming agent should you use? And that can tell you how much to apply, and then you can adjust those recommended rates based on the liming material and incorporation methods. So, and also, yeah, please, if anybody has any questions throughout, because I'm going to move on, but if you have any questions about pH and liming, or if you, I can answer them at the end as well. Yeah?
I'm sorry, I'm struggling to find the recommendation for liming.
It's on the bottom.
It's the second last.
Second last, yeah.
Okay, thank you.
Yeah. And so it's important to, when you're submitting your soil test report, to also put your crop. And so like if you, I always use blueberries as the example because it's the easiest one, but they prefer a much lower pH. So they typically wouldn't have a lime recommendation if you're within that range. Do you have a question?
I was just wondering, I don't know if it's relevant for other people, so it could be later, but if you can speak to when your pH is actually too high.
Yeah, so there are, so typically if your soil pH is too high, there are amendments you can add. So one of them is elemental sulfur, and so that will acidify your soil. There are some other options, but that's typically the main one that, yeah, so sulfur is an acidifying agent. Yeah. Yeah. So, and I have seen that a bit, especially in some of the smaller scale, like you know, the more samples you get, the better. You can monitor your pH a little bit more, but it can be easier on the smaller scale to over apply lime. So you need to be aware of that as well. Did somebody have a question over here? Okay. Yeah, so we'll move on to organic matter. Organic matter is so important. So very quickly, these are an example of some of the major sources of soil organic matter. So it's the combination of living and dead plant and animal matter in your soil. And it helps with so many things. So it supplies nutrients, it adds soil structure, it increases water holding capacity, so it reduces the risk of erosion, increases biodiversity in your soil. It has negatively charged binding sites, which promotes nutrient absorption. Because as we saw earlier, we have those cations that are positively charged, so you need those negatively charged sites to bind them. And we'll talk about that a little bit more when we talk about cation exchange capacity. So in this talk, we'll talk a little bit directly how it supplies nutrients, because we're talking about nutrient management planning, but all these other things are very important, especially when you're thinking about your soil structure and trying to reduce erosion, because those are factors that are potentially going to lead to losses of nutrients on your farm. So when you're talking about nutrient supply from organic matter. So one thing when you're connecting organic matter to pH, because it has those negatively charged binding sites, it can help offset some of the consequences of low pH because it will bind to those base cations and keep them in your soil. So when you have organic matter, plants cannot take up nutrients in their organic form. So they must undergo mineralization to transform them into inorganic forms for the plant uptake. So when we think about those three things I talked about for your plants, your nutrients to be available, one of them is that your nutrients have to be in a plant available form. So an example, just the plant available forms for your 3 macronutrients and secondary nutrients, or if you consider them 6 macronutrients, but these are the plant available forms. So for nitrogen, NO3-, that's nitrate, and ammonium. And so in order for the roots to take up nutrients, they need to be in this form. And if you want to know the forms for the other micronutrients, we can talk about that as well. So when organic matter undergoes mineralization, this is the breakdown of organic matter so that it goes into those forms that the plant can take up. Now, this is dependent on soil moisture, temperature, the C to N ratio, microbial activity, pH, and other soil properties. So, and some of the big 3, so we'll talk a little bit more when we get into the other talks. You're supplying nitrogen, phosphorus, sulfur, and other micronutrients, but those are some of the more really important ones. So the next one, so on your soil test report, your organic matter is second from the top, and it's in a percentage. Oh, yeah.
Did you have a question?
Well, that's what I was going to ask. What percentage of organic matter is good?
Any percentage you have is good, more is better.
More is better, yeah. So it can depend on your system a little bit too, but typically, like, I hope to see over 3.5, but like in a no-till pasture system, you could have, like, I've seen soil test reports from out west that are like 11, 12%, and they're like, that's great. So typically more is better. And when we talk about soil health at the end of the day, I do have some like ranges for that we can, yeah. Any other questions? We're gonna circle back to organic matter because it's so important and ties to like everything in soil. A lot of issues that you have with soil, you can use organic matter or organic amendments to help improve those issues. Yeah, so the next one on your soil test report is cation exchange capacity. So I show where this one is because it's kind of in the middle here. So it's represented in milliequivalents per 100 grams, which might not mean a whole lot. But what's important is that cation exchange capacity is the total amount of exchangeable cations that a soil can absorb. So it basically represents the ability of your soil to retain those nutrients. So you'll have these negatively charged sites on your soil on organic matter and in clay. So if you have very sandy soil with low organic matter, you typically won't have a very high cation exchange capacity. And what that means is that your nutrients may be more prone to leaching. So this contributes to the buffering capacity of the soil, which is the ability of your soil to resist changes. And so as I said, it's dependent on the amount of soil organic matter and clay particles in your soil. And it can typically be difficult to alter because you can't really alter your soil texture. But you can increase your organic matter, and that can increase your cation exchange capacity. So this is just an example of what happens in cation exchange. So you have either a humus particle, so a soil organic matter particle, and a clay particle, and these positively charged ions exchange in soil solution and then can be taken up by the roots. So we talked about plants being in the available form and then also being in soil solution in order for them to be taken up, so soil water. And so that's the second thing, so that occurs by cation exchange. So this is a fun little comic. There are different ability for different nutrients to be retained on the cation exchange complex, so on these negatively charged ions. I won't go through all of this, but basically they can bump certain ones off, and so there's an order here of which cations prefer to be on the cation exchange, not prefer to be, but which ones have a stronger ability to bump the other cations off. So that can play into it as well. So for cation exchange capacity, what do you need to know when you're thinking about nutrient management planning? So as I said, it's based on the amount of clay and organic matter in your soil. It's on your soil test report. You can increase it through organic matter additions. But what it may impact, and we'll talk about Rosie will talk about the 4 R's, but when you're thinking about timing and the rate at which you want to apply. So if you have a clay-heavy soil with high organic matter, you're going to have more ability to retain those nutrients. So if you have a sandier soil with low organic matter, you may need to apply amendments in lower amounts but more frequently because that soil can't retain all those nutrients. So that's something to kind of consider. And I have a bit of a visual. It's very simple. But if you think of these different size cups as different cation exchange capacities, basically I poured the same amount of water into both. And in the smaller one, it overflowed, and that's representing your leaching. So if you have a full nutrient capacity, if you have nutrients in your soil, then now that one doesn't want to play. Oh. Anyway, oh, there we go. Yeah, now they're both playing. But basically, this is representing, okay, your plant is now taking up some of these nutrients, and then you can replenish it. But this would represent kind of a sandier, low organic matter soil, where the other one would have a higher capacity. So that's just something to consider. So we've talked about that your nutrients need to be in a plant available form. We've talked about that they need to be in soil solution and how they get there. So then once that happens, how is the plant actually taking up these nutrients? So there are 3 different ways that the plants will take up nutrients. So root interception, mass flow, and diffusion. And I'm just going to go through them very quickly, and we'll talk about them a little bit more when we get into the specific different nutrients. So the first one is root interception. So this requires direct contact with the roots or associated mycorrhizae. So it depends on the size of the root zone, and so different crops have different size root zones. And so that it needs direct contact with the nutrients in order for them to be taken up. The second one is mass flow. And this is when nutrients are carried in the water, and then plants take up that water with the nutrients in it. And so this depends on the water use of the plant, and it depends on the concentration of the nutrients in the water and the movement of water through your soil. Third,
Mass flow basically means that's the soil solution, and with root interception, it isn't, or they both require.
So it still has to be in soil solution, but basically when the nutrients are in soil solution, they can come into direct contact with the root in order to be taken up, or the water can move them to the root and then they're taken up. Okay. So then with diffusion, it's the movement of nutrients from a high concentration to low concentration. So basically it depends on your soil moisture, it depends on your plant demand, soil texture, and soil nutrient content. But this also requires for nutrients to be in close proximity to the root. So you may have different concentrations outside the root, and then that allows it so that in diffusion you want it to be equal concentrations within and outside the root. And we'll talk about that a little bit more. But what's important here is this is a table describing how different nutrients are taken up by the 3 different methods. So typically, a lot of these nutrients are taken up by mass flow. So something like nitrogen, that would be nitrate, it's really soluble in water, so it can be moved in water. Potassium and phosphorus are taken up by diffusion. So how this impacts when your nutrient management planning is those nutrients you may need to change the type of application method so that they are in closer proximity to the root, because they are not mobile in water. Yeah.
So do tillage practices have an effect on diffusion? like i.e. like no-till, for example, would that disrupt?
I mean,
Yeah,
Yeah.
because like in no-till, typically you're putting your nutrients on the soil surface, right? And that's not where your roots are. So for things like your potassium and your phosphorus, like you really need to get those nutrients down to where those roots are. So if you can knife it in, for example, in a no-till system, you would have better crop uptake of those nutrients.
Just so, how are you getting percentage over 100?
yeah, so we wondered that as well. And so that would likely just be the luxury uptake. So something like calcium, plants only require a certain amount, but they're able to take up more. So it's
So it's percentage of need, but not percentage of what it takes.
yeah. So we looked at that, and Tim and I discussed that earlier. Where did he? Oh, there's Tim. yeah. So quickly, just to wrap up here, so when we're talking about nutrient management planning and organic matter and nutrient uptake, some of the things you want to consider is the organic matter supplies nutrients. So Rosie and Tim, they're going to talk about more of the amounts. So they're going to talk about how those nutrients are supplied. And then organic matter can affect the soil structure and the cation exchange capacity, which may impact the availability of nutrients. And then the nutrients are taken up by plants in different ways. It's important to know how those different nutrients are taken up because that can alter the timing, the placement of your amendments. So that was a very brief overview on pH, organic matter, and cation exchange capacity. But what I'm hoping you guys got out of that was how it would affect how you would alter a nutrient management plan. Does anybody have any questions before we move on to Rosie?
Did you already answer this? How do we, is the buffer pH useful?
Yeah, so the buffer pH, so in pH, the pH is the measure of the active acidity, so what's in the soil solution. The buffer pH represents what the hydrogen ions that are tied up within the soil. So what the buffer pH is typically used for is to determine your lime requirement, but that's more used by the lab. So that's not, so typically it's not really one that you need to worry about as much, but it's used just to determine the lime requirement because it gives an indication of how difficult it is to change the pH in your soil or the buffer capacity. So when you have a higher buffer capacity in your soil or a lower buffer pH, that means that it may take more time and more lime to change the pH, but that also means that it would take more effort for it to increase, but also more effort for it to decrease.
So if it's higher, like for instance here we've got a pH of 6.04 and with a buffer pH of 7.83.
Yeah.
So the higher the buffer pH, the less we need to apply?
The higher the buffer pH, the lower the buffer capacity. Yeah, so your pH would be would require less lime to change. It would require less time for it to change when you're applying that amount, but then it would likely decrease quicker, if that makes sense.
I think a good way to think of it, perhaps, is it true that you start with a buffer solution at 7.5, you add a specific amount of lime, and however high it is charting how high it moved from that baseline?
Yeah.
So the higher the number, it means it was more sensitive to lime. So it's an indication of how sensitive a given soil is to application of lime.
Yeah.
So the higher is showing that it moved that much higher from 7.5.
Yeah, because you can have the same soil pH and you can have different buffer pHs, and you could potentially have a different lime requirement because that soil is less sensitive or more sensitive to changes in pH from lime.
Yeah, so when you're looking at your soil test and trying to make decisions about it, really the buffer pH piece of that puzzle has already come into play in that lime recommendation that's down at the bottom of your test. So like it's good to know what your pH is, and it's good to know what your lime recommendation down at the bottom is. And I often just ignore the buffer pH unless I'm talking to Caitlin because she likes to talk about it. But it's all spelled out, in that excellent handout you put together.
So this is an example. This is this is the soil test report interpretation for Nova Scotia. So it does give a graph of the buffer pH and then the lime requirement. This is Nova Scotia data, just from a bunch of different crops, but it kind of shows you that there's ranges, but typically the higher the buffer pH, the less lime is required to change. However, you may need lime more frequently because that would likely indicate that you have a lower cation exchange capacity. So all these soil properties are linked, but like Rosie said, from your perspective, the buffer pH is not, it's important, but the lime that value is reflected in the lime recommendation. Any other questions? Yeah.
So Caitlin's slides are in all of that packet that was at your seat. So Caitlin's slides, my slides, Tim's slides are all there. There's a bunch of different handouts. So while I load my presentation, take a minute to kind of familiarize yourself with those. There's some dummy dummy soil tests and some dummy compost analysis there, which you might also find helpful if you didn't bring yours to the party.